Hello, everyone. We are going to be talking today with Kipp Bradford. Kipp is an amazing person, and I have needs because I need to break an HVAC system on Mars. Why is Kipp so good for me to talk to? Kipp Bradford brings almost 30 years of experience as a technology innovator working at the boundaries of emerging technology and industries. He was a senior research scientist at the MIT Media Lab, hired as a result of the professor of other faculty search for an interdisciplinary scientist. His work has been called so interdisciplinary, it's anti-disciplinary. He was also recognized as a visionary innovator by global strategy consulting firm Frost & Sullivan. As an academic researcher and educator, Kipp's work merges biology, ecology, and thermodynamics to develop new ways to use energy more efficiently, which is why he is so good for me to talk to about breaking things on Mars. He was a presidential fellow at Princeton University, working with the Chaos Lab at the Andlinger Center for Energy and the Environment. Kipp was also faculty at the Yale University School of the Yale University School of Architecture, where he worked with the Yale Center for Ecosystems in Architecture. Currently, Kipp is an adjunct faculty member of the Harvard University School of Engineering. And as a business innovator, Kipp applies his skills as a complex system architect whose work focuses on developing business models that create frictionless frameworks. These frameworks are technology-driven products or services that maximize efficiency in a given value chain. He is a sought-after expert advisor for companies ranging from hardware-based startups to large global corporations and also science fiction writers. He also co-founded and currently works as the Chief Technology Officer, Chief Innovation Officer of Gradient Inc., a spin-out of the San Francisco innovation think tank Other Lab. I am delighted to have Kipp with me. He has been helpful in the past, and I'm very happy to welcome him here to talk to you all. Basically, he's real smart. And he knows a lot of things that are very helpful. So I am going to invite him to share the stage here with me. And we are gonna talk more. Now, if you are watching this on Zoom, I want you to know that this is also part of my Patreon, Interviewing Experts. If you want to be able to ask questions, you can quickly join patreon.com/Mary Robinette and hop on into the Zoom where we are doing this live. The first half of this interview is with you all, and then the second half is just members only. So hey, Kipp. How are you?
Good evening, Mary Robinette. I'm doing well, thank you. Other than dumping water on my computer yesterday and having to set up a backup computer for today,
Oh my
everything is
goodness.
good.
I have definitely been there, done that more than once. Sadly, I usually
Yes,
blame my cat. That's what my recommended strategy there.
that cats are good scapegoats, or
Yes,
escape cats, as the case might be.
yes. Um, so uh, one of the one of the things that I need to talk to you about is this whole idea of HVAC on Mars. So we're going to start with some framework first. So I know that I read your bio, but I'm going to start with the question that I ask all of my guests. So there's your bio, but what do you actually do?
That's a great question. On a day-to-day basis, I do one of two things. One is strategy, business strategy, trying to keep a startup pointed in the right direction so that it can make transformative change in the world. And specifically right now, as you mentioned, I work at a company I co-founded called Gradient. We have a purchase order for 10,000 units of our product for New York public housing in order to decarbonize buildings in New York City.
Oh, wow.
We have a lot of interest in the product in general for decarbonizing buildings as a very, very quick and easy way to upgrade existing equipment to things that run off electricity and run more efficiently. So a lot of business strategy, a lot of market strategy, and managing smart people who hopefully are smarter than me, but still need to be managed. And then I'm also something of either depending on your which analogy you like, a smoke jumper, in soccer I'd be considered a sweeper, and maybe the utility infielder in baseball, but kind of jump around, solving mostly technical challenges that involve electronics, software, mechanical systems, thermal systems. So my background is actually biomedical engineering, which there's a longer story that I won't tell here about how I got into HVAC, heating, refrigeration, air conditioning, etc. That tracks through biomedical engineering. That it was really out of a medical and comfort perspective that got me into the field.
Oh, interesting.
But my background as a biomedical engineer was really diverse in terms of like biomedical engineering when I started was a newish field, and you really had to develop cross-functional skills. So I studied materials engineering, and I studied chemical engineering and mechanical engineering and electrical engineering, and to the level of expertise that I could solve fairly complex problems in any field. But the real specialty became that ability to see across those disciplines and understand where I can solve a thermal problem, maybe not with a mechanical engineering solution, but with a software solution or a systems level solution. And that really becomes important and critical looking at some of the more complex problems that we're dealing with, especially around energy and environment and building comfort. There's a lot there we've been hammering on these problems for decades with traditional engineering skills, and it really requires a new lens in order to see novel solutions.
Yeah. So can you tell me what decarbonizing buildings means?
Yeah. So buildings have a ton of embodied carbon. When you build a building, there's lots of concrete, there's lots of wood, lots of materials that go into that building. There's also the carbon generated from using the building, whether it's the electricity
Right.
for lighting. A large portion of energy use in buildings comes from heating and cooling and hot water, air conditioning, just keeping the building warm in cold climates. And a lot of that energy usage is generated by fossil fuels. So we have coal, gas, and oil that drive enough of our power plants that operating a building has a fairly large carbon footprint. And one of the very straightforward ways of reducing that carbon footprint in the operating of the building is switching as much of the infrastructure in the building to be electric only, and then switching the supply from coal, oil, natural gas to renewables, wind, solar, geothermal, hydroelectric, etc.
Cool. Sorry. If you couldn't tell, I am taking notes below the screen with like actual utensils there.
This is I am analog like that too.
Right. So I'm gonna start going into specifics of the problem that I'm facing right now,
Yes.
which is the fun part. So I'm just going to briefly reframe because I don't expect you to remember a conversation that I think we had in 3 years ago, maybe 2 years ago. I think it was in the before times.
It was just after the beginning of the pandemic.
Okay, it was. Okay.
Yeah.
So this novel is set on Mars. It's the second Mars expedition. It takes place in 1969, which means that because I'm in an alternate history, I am allowing myself to use technology up through the 80s. And then after that, I can kind of pick and choose. I can be a little pick and choose some things, like computers, less so. But hey, did you know that this fascinating way of assembling something works much better? Like that kind of thing. In part because and environment is one of the areas where they can be more advanced because I slammed that asteroid into Washington, D.C. in 52. So they've been very focused on environment and greenhouse effect, and renewables. Also renewables like solar, for purposes of being on Mars, and nuclear because, again, Mars and the moon. So there's a I can explain in detail after we stop the recording. I will just say that that there is a problem with the HVAC unit. Let me rephrase that. They need to set up 3 domes, and for reasons, rather than having, and it's HVAC. You don't say HVAC. You say HVAC.
I tend to hate abbreviations and acronyms, especially
Right.
3-letter acronyms. 4-letter acronyms are just slightly better, just because of familiarity. I don't want to put off people who know what an air conditioner is, but don't know what an HVAC is.
Got
So
it.
I tend to say HVAC or even air conditioning and heating.
Cool. I ask partly because I am going to have to narrate this book, and I want to make sure that I am saying it correctly.
Both are acceptable.
Okay. Um, cool. Well, we'll figure out which ones my characters use. Actually, they are all space people, so it probably is HVAC for them, because astronauts have never met something that they can't turn into an acronym.
Exactly.
Um, so anyway, so for reasons, they want to set up 3 domes, but they only, and the original plan is to have an HVAC unit in each dome, but for reasons, they have only 2. So the things that I need are how to handle heating and cooling in the dome that, in one of the domes, without its own unit. And then also things that can go terribly, terribly wrong. I have some things that would be ideal to use, but let's start with general terms first. And kind of in anything that springs to your mind from that scenario. And feel free to ask me questions about like what the Mars habitats look like and things like that, because I unfortunately know the answers to that, or fortunately.
Well, it's a great question to start framing. Mars is an interesting environment in that it's very, very, very cold, and it also has very little atmosphere,
Hmm.
which means that on the one hand, you would think, well, it's cold, so we really need to be doing heating, but there's a need for both heat and for cooling because whenever there are any processes taking place, biological processes, chemical processes, fabrication, you generate heat, and that heat has to have somewhere to go. So, yeah, on Earth, we can dissipate that heat into the air. We blow air over a heat exchanger in a car or an air conditioner or power plant, and you can reject that heat because air has a decent amount of thermal conductivity, but there's enough density so you have the mass required to carry the heat away. You don't have that on Mars. And I think that's an interesting question of how
Hmm.
do you dissipate the heat that's generated? If you think about The Martian, one of the critical problems that the protagonist faced there was staying warm, and that is definitely a problem. If the heat that you're generating and the insulation you have is a spacesuit and you're trying to stay alive as you're navigating the surface, say. But rejecting heat is also a big challenge if you're generating heat, or there's a lot of sunlight that's incident on your habitat, and that solar radiation carries a lot of energy with it. So both heating and cooling are challenging problems. And then the second piece, that the assumption that I would make is carrying mass up to Mars is hard and expensive.
Hmm.
So I would want to have a system that has as little mass as possible, i.e., if you can take advantage of materials, stuff that exists on Mars, then you would do that rather than flying it up there. So those are just the things that are in the back of my mind, um, helping frame out my mindset. So I do have some questions, which
Yes.
is you've got 3 domes. How close are the domes together?
So one dome is already constructed. And then they are in the process of building the second 2 domes. And let me back up briefly because I said domes. The plan that they had was there's one dome, and then there's a second dome, and then they go into the wall of we're in Gale Crater, so they go into Cliff Wall after that point. Um, so it is still going to be a dome because they're doing inflatable habitats. So they're still going to carve something out because that's a very stable structure. But we are going into cliff wall at that point. Since they have not, where we are, where we begin the book, the point at which they discover the problem, they are in the process of excavating the hole for the second dome.
Gotcha.
So they would have the option of changing their mind. Under normal circumstances, it would be about 20, they would be about 20 meters apart.
20 meters, not that far. So I'm picturing first dome, there's some kind of heating cooling plant. Carbon dioxide tends to be a pretty useful substance in heat pumps.
Oh, cool.
It's runs at higher pressure than other things, but it would be kind of the obvious solution that um, when you want to actively move heat and cool around, you would use a heat pump to do that. And the obvious working fluid, the thing that gets compressed and expanded in the heat pump, would be carbon dioxide. So you'd compress it, you'd reject the heat and turn it into a liquid, and then you'd expand it when you wanted that cold again.
Mm.
Because of the thin atmosphere and the inability to really reject heat into outer space, one way to tackle that problem would be to use all of the surrounding ground
Mm.
as your heat sink. And one of the things that would be possible in a situation like this would be to store liquid carbon dioxide. So you could have a system where the heating and cooling capacity of these domes is generated by some system which initially collects carbon dioxide from the atmosphere and then compresses that carbon dioxide, and then rejects that heat into the surroundings. But now you have a some storage volume of liquid carbon dioxide that can then be expanded again when you need cooling. So it allows you to generate heat. That heat can be rejected into the ground or recuperated into the building, and then you have the ability of boiling off the liquid carbon dioxide effectively and using that for cooling.
Ah, okay. What, so that is very cool. So what are the kinds of things that you would need? So let's assume that, let me try that question one more time. Is that the kind, if this sounds like the kind of system that they would go up and they would plan to have because it's utilizing resources that are in situ. So then is that the kind of thing that they would be able to potentially scavenge parts from another, from something, since people send redundancies up all the time? Like what would you need to build one if you had to build one?
If I had to build one, I would scavenge the fuel tanks from the rockets. It's a little tricky because landing, again, flying the mass up is hard, and then landing the mass on Mars is pretty hard. But we're
Hmm.
assuming that there's a way to land the mass on Mars.
Yeah.
So, SpaceX is landing rockets on Earth. Uh, yes, this is 2020 something, but there's nothing inherently technically impossible about that. It's just it's hard. It's
Yeah.
guidance and computers and stuff. So, assuming we get to Mars, which requires the ability to land stuff on Mars, and
Mhm.
some of the stuff we're going to land on Mars will be fuel tanks that will then become emptied in the process of the transit, the journey. And when those land, you now have a tank that can hold, that's been designed to hold pressurized uh, liquefied oxygen or liquefied
Mm.
hydrogen, which it liquefies at higher pressures than carbon dioxide. So now you've got a really nice pressure vessel that can store those that liquefied refrigerant essentially. So that plus scavenged heat exchangers from the rocket motors work pretty well. Running those heat exchangers again using the mass of the ground as essentially it's the equivalent of a geothermal heating cooling system where you're using the thermal mass of the ground as a way to absorb or reject heat as a heat sink. And that heat sink then allows you to manipulate the carbon dioxide in ways that could produce the gases for you, but you still need to run pipes through the ground. So scavenge those heat exchangers and the pipes from the rockets, scavenge the tanks, and the turbo pumps that are in the rockets are the wrong style of pump for this kind of compression work, although they
Mm.
could be adapted for that, but they're not going to be as efficient or effective as kind of a slow speed compressor, but they could still potentially be utilized. But some kind of compressor, nothing special there, and then the ability to just collect that carbon dioxide from the atmosphere, compress it into the system, and then expand it as needed.
Cool. Um, all right. I have more questions, but now we have hit the part where I'm going to have to go into spoilers, which means that for our lovely, wonderful viewers who are on YouTube, that it is the end of our time together. Again, if you want to join the conversation, you can hop over to Patreon. The rest of this is going to be recorded just for my Patreon subscribers. But now, Kip and I are going to go into the privacy of backstage so that I can ask questions that are really super specific, giving him some more detail about exactly what happens to this while we are on Mars. Thank you all so much for joining us.